So we focus on many things actually. Uh, we focus on uh, system hardening. Focus on the cluster hardening, right?
Mhm.
We focused on how to image and all secure the image, right? So system is
Yeah.
done, cluster is done, image is also fine. Then you will also be focused on that like runtime environment and all that also be taken care. Now we have to focus on the application side also, right?
Okay.
Applications means the one which you are running. I'm talking about the microservices. So how do we see that the microservice, the application, user application which you're running, that is also secure or not? So let's focus on that part right now. So we'll discuss some of the scenarios here and security policies in Kubernetes, why policies are important, how to implement the policies you decide to use, what we will get out of this module in this like Kubernetes environment, and some of the security policies we'll discuss. So here, let's say Jen is a security consultant, and there's one company which has happened some data breach. So now we have to do the audits Kubernetes cluster. So how to get started? Not only audit,
Mm-hmm.
but also we are going to see that what are the policies is there, what is allowed, what is not allowed, the access of it, applications, communications, you want to track of it. So everything you are going to do that. So for this, we have some of the application which is like a PSP, OPA and all. For the security context, we need to also manage the Kubernetes secrets. Okay, we are going to also check that some of the output from the gvisor and kata containers and stuff like that. And also we're going to check that multis actually, which is implement pod to pod encryption by use of MLTS multis. So these are the things which we are going to discuss about it. So this is for the just this is about it, to find out the microservices vulnerabilities and stuff like that. So threat of
Mm-hmm.
misconfigured security policy. So how do we use defense in depth of to reduce the impact of compromised microservices? So first of all, host. How do you explain the importance of security policies in Kubernetes? So security policies basically is a policies to work along with the Kubernetes declarative style. Declarative style
Mm-hmm.
means YAML file to ensure certain
Mm-hmm.
policies, certain security focus rules are followed by the containers running within the cluster or not. So that's a security policy. So for example, this is the one of the scenarios you can say. So when you travel to somewhere, to some airport, then what you do? Gather luggage and drive to airport. Security checkpoint happens, and security checkpoint happens. Then you show your ID, boarding pass. Again, check for the contraband within a carry-ons, and stop if something is not right. So this is something what we have in Kubernetes also in form of security policies. When you run some applications, when you access some applications, so certain policies should be always checked, and then
Mm-hmm.
if everything is okay, then it should be allowed the communication. So how do we set the security policy? So in Kubernetes, we declare the security policies using YAML file. So create a config. Okay, so decide how the containers run, under which user ID and stuff like that. That is you can do through the YAML file. After that, compliance check. So do new container match the rules? And after that, if rules are, you can reject or pass. It depends on the violators rejected, allowing those in compliance. So
Mm-hmm.
this is something which you have to write it, all this thing in a declarative mode. So
Okay.
first thing you have to write what should be check, then check that whether it's rule matching with the rules, and third, violations, rejection or pass. So why is policies are effective? So it is declarative and it's automatic also. So you define the rules and Kubernetes enforce them. Very simple. So you will declare the rules and then Kubernetes will enforce them and allow, pass or reject. So here set it and forget it. Every object means primarily we are talking about the pod actually, because no matter what you do, uh, whether you use the kind pod or RC or RS or deployment or daemon set or stateful set or any other ways to deploy the pod. Ultimately, you run the pod, correct? So every object means the pod must pass the test to be allowed into the clusters. So that is automatic. So using the pod security policy to protect your cluster. So RBAC is not enough. So for that reason only, we are using PSP, which is a PSP apply across the cluster and which is scalable also. Where RBAC is not enough because you know that it gives a high level permission, not the fine grained rules for it. Okay. So this RBAC we have covered already. So
Hmm.
how
Right.
to work with it. So this is the Kubernetes creation workflow. First, you decide authentications for using the different method which we discuss. Authentication method which we are using is certificate based and token based, but few other authentication method also can use. Authorization we discuss about using RBAC, correct, no?
RBAC.
Yeah,
Yes.
and pod security policies, which we are going to discuss now. So these are the three ways in which you can create a flow for securing the pod. So yeah, privileged. So this is the rules actually. Privileged is equal to false or true, and if it is false, then you are stopping that pod to access the kernel. So yeah, so recommended. So Kubernetes recommend pod security policies actually. So here, if you see that one of the policies there, just one example about the volume.
Mm-hmm.
So do not allow host path volume within your container. Now the question is, what is a host path? So if you remember that in the volume, persistent volume types, host path is one of them, right?
Correct.
Yeah.
Yeah.
So we have a see. If you go from the scratch, then you will have a empty dir, and after that host path. Uske after that NFS, after that config map, and then secrets for the cluster storage, and after that you can talk about any block storage, other type of cloud storage and all stuff like that. So here, yeah, some of the security examples like port security policies like do not allow host for volume within your container, but allow
Mm-hmm.
value from for volumes for the pod, config map, downwards API, empty dir persist PVC, secret and projected. So here it is allowed and host path is not allowed. One of more, so what you do, recommended security policy where host ID do not allow host pid to be set to be true within a container. This setting allow the container to see the host processes. Could allow an attacker to gain more information for the next attack or kill processes. So look at this here. How do we implement the PSP? So at the this is a pod spec actually. So pod spec, and then inside the container you can say node restrictions and enable admission plugin node restriction. PSP you can enable it for this,
Yep.
and these are the security context options which you can attach to the pod specifications. Allow privilege escalation boolean so true and false capabilities, privilege rate, proc mount, read only root file system, run as a group, run as a non-root, run as a user, as C Linux options, CCOM profile and Windows. So these are the options which is some of this has been taken from the documents. Each of
Mm-hmm.
these fields has a certain policies which will validate or not. You can give it. So look at the value boolean and string boolean integer and all these things you can fill this. Look at the example of it. One of the pod, how to define the security policy in the pod spec. So here you have a
Mm-hmm.
context set saying that this pod has to run as a only 1,000 means what? Any idea?
User ID.
User ID, group ID, and FS group. Okay, file system group 2,000. So these are the security context. If you look at the bottom side also, some of the security policy you can set at the container level also. The security
So
context.
how? Sorry. Yeah. So how this runners group, runners user is identified? So we must have someone must have created that user, right? Like that or?
See, okay. So I think you should, for this answer, uh, you should go for this one. mm, Docker file, and which one I should show you? Jenkins example. So this is the one application production IO, not this. Just a second, hold on. Docker Hub. So this is one of the production ready applications, and let me show you the,
Mhm.
just a second,
Yeah.
Docker file. So if you go to this file, you will have answer for that. So here you see that user is here. So that means this container will run from the user, which is a variable from top, which is Jenkins, UID 1000, GUID 1000. So you are setting
Mhm.
up in the Docker file. Now let's say, in a simple way, if hacker is hacking your systems, so of course that will be different user ID, right? Correct, na? Because your
Mhm.
application anyways is running with a 1000 user ID, right?
Mhm.
You remember?
Correct, correct. Yeah, yeah, yeah.
So that way it will not allowed actually in your case. In this case, it will not be allowed. See here. So
Mhm.
policies say accept or reject, pass or fail. So if it is not following this one, then it will not be allowed,
Mhm.
correct?
Yeah,
So
yeah.
if, even though
Got
if
it.
you got access to that container, you cannot do anything.
Correct. Yeah.
Yeah. So this is something which you can write in the pod specification, some of the settings for the container specification and so on. So yeah, this was a simple example actually. So, and here you can check this out. Opa, okay, so this was the pod policy specification. But what about if you want to do for the at the enterprise level, to check all the pods and implement all these things? So what you can do, you can install the Opa as an operator using Helm or something, and Opa is another product of the CNCF. Remember that. So you can implement that OPA. So OPA, Open Policy Agent, is an open source general purpose policy engine, and it uses the defined policies to make decisions on your applications. With OPA enforcement, is decoupled from the decision making. Your application, or in our case, our Kubernetes cluster must enforce the decision made by OPA. How can you install it? So installation will be done by Helm. So multiple documentations you have, just it's another product, again you can check it out here. And now look at this here, how it works. So how OPA policy evaluate the pod policy. So here you look at this. uh, OPA is running with a service, and OPA has a policy, database, and data JSON and stuff like that. So whenever that some pods is being running in the Kubernetes environment, it make a request to the OPA service, and OPA service check the policies and see if it is pass or fail, and depends on that pass and fail, that process gets started in the pod. So this is something which you have to understand that. So admission controller ask OPA for decision. So when you install the OPA as a operator, then it will be running as a, it will be become one service in your Kubernetes, and you can call it anytime. So the OPA is a one product. Opa Gatekeeper is another product. Remember that. So Opa Gatekeeper is another product,
Okay.
which using that you can validate, using webhooks you can validate it and audit and stuff like that. Do you know this product which is called? Mm, see, I forgot. Do you know this product which is called mm, Argo CD? Yeah, Argo CD.
I've heard the name.
Yeah.
The
So
It's for
if you,
implementing
yeah. So if,
CI/CD, right?
yeah, so if you want to implement the CD using on the container technology like a Kubernetes and all, then you can use Argo CD. Okay. So Argo CD also, my videos will be on YouTube, so just check it out actually. So so yeah, so you can integrate with OPA Gatekeeper
Okay.
with Argo CD and Kubernetes, so it will be helpful for you. Now look at this here. This is the Gatekeeper code. So if you install that controller, the custom operators and all,
Operate Operator, right?
yeah, no operator Actually, there's a one thing we need to understand. When we say operator, operators are nothing but a custom controller, okay? And we install through the CRD, custom resource definitions. So
Okay.
when we say operator, it's nothing but a controller only, but it's a R controller. Getting my points?
Yeah, got
Yeah.
it.
So we install this through this, and after that you can call that these policies in your Kubernetes clusters and run it actually. So this is the pod specifications, and when you run the pod, you will have a warning. Okay, see, look at this warning. So at the pod level, you don't have to specify the policy because you have applied at the Kubernetes cluster level. So this is the moment you install the Opa Gatekeeper in your Kubernetes, these are the resources you can use it. Kind, you look at the kind, and these are the resources you can look at this. And after that, when you run the some pod, let's say kubectl apply pod, you will get a warning saying that okay, prod repo is open policy agent, container nginx has invalid image repo, and nginx allowed repos are only this one. So something like that you can
Mm-hmm.
do that. So this is the stuff. Yeah. So the question is very simple. Secrets are hard coded in the container image,
Mm-hmm.
and at the some location which is mounted, and that you know that, correct? No?
Yeah, yeah.
Yeah. So the question is very simple. How to use Kubernetes secret to store to protect sensitive data? So this is something which we have to work on it. So we know that very well. Uh, Access to the repo, access to the credential which is exposed, lack of separation, dev knows the production secret, rework new credential, new container image and all, always is keep on working. So these are the danger of hard coding secrets. So
Mm-hmm.
what to do? So Kubernetes secret preferred architecture. So here, um what we have, these are the options which you can use, which what I talked about it. So either you use the secret in the Kubernetes, the one which you're using, which is not secure, or either you migrate the central secret store to one of these options, which is Kubernetes secret store. That's one product. Or you can use Vault. The one again is open source, cloud provider like AWS KMS, Azure Key Vault, and stuff like that. You can provide it and you can integrate. So now the question is, how do you integrate that? So when you install their operators, for example, Vault operators is been installed easily. In fact, you can use a Kubernetes secret store also. So you can select like okay, when you create a secret, here you specify the type and the name and data. For example, here
Mm-hmm.
you are saying hey kubectl create secret generic one, and name of the secret is and from the file. After that creating a secret, okay, what you need to do, this data need to be encrypted with the Kubernetes secret. So what to do, so how to protect the secret? So this data uh, will be sent to the this Kubernetes secret store, and from there encryptions will happen, and encrypted data will be stored at the etcd. Now the question is, how do you decode that? So while using the secret in pod specification, you will have also one kind encryption configuration and decryption configuration. So there's a whole hell lot of document. If you follow that Kubernetes encryption documents, this is the
Yep.
downside link which you have. So using that, you can decode that encryption and then use in the pod. And also there are few things which you can do, follow the process, like always encryption key or encryption and decryption key both, you can keep rotating it, and you can set the policies for that in a KMS or something like that. KMS means uh, AWS
Key
KMS.
management. Mm-hmm.
AWS KMS, yeah. So there you can set that encryption, data encryption by data keys which are encrypted by keys, encryption keys and all, and rotation schedule and all this you can also do that. So this is at the high level uh, uh, architecture for EKS actually. So here you see that they're connecting with the KMS, which is a IAM service, one of the IAM service to encrypt the and decrypt the data. So you can use it also this one.
Mm-hmm.
This is the using the RBAC to protect secrets. So here you are using RBAC to protect secret. That means you are not allowing everyone to see that get to watch a list and stuff like that. So you can also do that, these operations.
Mm-hmm.
Okay, so this is the something which you can try. Now let me show you here. Yeah, so let me show you here how can you install. Let's say HashiCorp Vault is a very popular solution. So HashiCorp Vault install operators Helm chart in chart. So you can install this one Helm chart. Yeah, so you can install this one, and after that, after installing this, how can you protect? So here some sample code for this Kubernetes pod using HashiCorp Vault. So this is the one injecting secret into the Kubernetes vault by a agent or So sidecar container. So here this tutorials will have some code. Okay, this will have some code which you can try it out and encrypt that. Yeah.
Okay.
So here you see that. Yeah. So for this vault knowledge, you need to have it. How do you get this? So try my videos on YouTube, HashiCorp Vault, which you can
Okay.
get it some idea about that.
Mm-hmm.
Next topic is uh, just a second. Managing secrets. We did this. Next topic is so how do we set this policies? Uh, there's one more tool which is last tool actually. Uh, policies, security policies to secure pod to containers uh, connections. So how do you do that? So
Pod to container connection. Huh?
no, sorry, pod to pod connections. Sorry, that's just a second. Hold
Mm-hmm.
on. I'll directly move to the real one. Sorry, this
So
is
that is the network policy only, or
no. Just a second. Hold on. Wrong file I have opened. So that's a created a confusion.
okay, okay,
So this is the one. So securing pod to pod communications. So how to do that? So in simple way, there is one more tool which you can use it for this MLTS. So here, if you see that architecture, very simple architecture.
MTLS,
Yeah,
mutual TLS.
yeah. So here, if you see that this connection from outside, if you look at this from the client to the DNS and load balancer is HTTPS connection. But the
Mm-hmm.
moment it transfer from the ingress, you understand that, right?
Mm-hmm. Yeah,
Yeah. So ingress, then it become a HTTP because we know that after the ingress we don't implement the HTTPS,
encryption.
right?
Mm-hmm.
So all the TLS we stored at the ingress only, and after that it become HTTPS. But what we want that each service pod to pod also the connection should be HTTPS. So how can you implement that? How can you implement that? So for this, we need MLTS. Okay. So you keep
TLS.
yes. So here if you see that ingress to service and service to pod also we have HTTPS connections.
Okay,
So and here pod to pod and all this thing also. So what will happen? There will be each pod will have one proxy sidecar container. Okay, proxy
okay,
sidecar container which will have a certificate. So this proxy
okay,
will be talked to the server MLTS and always update the certificate and enable that. So how can we configure it? So look at this here. This is the one of the pod of the sidecar proxy pod. The image is Nginx, and here you are creating. Uh, here you are setting up the command, whatever you want to get it done, and after that you are setting up the some of the capability for the security context capabilities add and net underscore admin. So it's like a long program. So you can see that which will empower the HTTPS and the each pod and the MLTS can be configured. Now, one more way you can do that is Istio. You can implement the Istio also for
mm-hmm.
MLTS and get it done. So this is the way. You can configure uh, secure pod to pod connections also. Now, last one more topic which we have is just a second. Yeah. So how do we secure the container runtime? So we have discussed actually, but there is one kata containers also is missing. So here the problem is very simple. Are containers isolated from the host OS? Are the host protected from the exploitations and stuff like that? So this
Mhm.
is the discussion we made already, how
Right.
these things works. So I'll show you the directly implementation. So first thing, you protect the virtualizations level also. Then using the virtual machines, like multiple tools are there at the VM level, and rule-based execution seccomp, LAST, Linux, AppArmor, gvisor we discuss actually, and kata containers also you can use it. This is the
Mhm.
architectures you can see. So here what is happening, applications make a call to the sentry. Sentry is a basically run a secured runtime environment for the container used powered by gvisor, and
Okay.
for file system gopher is being used, and host kernel. So this way that the runtime environment can be protected. So this is something which you can also do some sort of practices. How can we secure the VM environment also, a hypervisor and stuff like that. So that is also important.
Mm.
Let's say if you want to only implement the gvisor, so you can see handler runtime class handler and sc, but here you can call that in the right side, you can call in the pod the runtime class name gvisor, and
Mhm.
this can be protected.
Yeah.
This is for the Kata. There's a one more product, Kata containers. I showed you
Mhm.
that URL for it. So here you install the Kata operators, and after that will become runtime. So after that, whenever you run the pod, you can call the runtime class name is Kata. So default, if you don't specify, then its default is run C. Default is run C. So you can say Kata, gvisor, run sc, multiple things you can set it up here actually.
Mhm.
So this is the gvisor anyways. Yeah. Yeah. So overall, this was the list of tools which you are going to work with it. Let's do the recap of all the tools from the scratch and practices. So it'll be good for us. So first thing, let's talk about the API resources uh, for security. So can you remind me all this API resources,
Network policy, like
network
that you are
policy?
saying,
Yeah,
right?
yeah, yeah, yeah. Network policy,
Secret.
secrets.
You're not saying about the tools. You're talking just
No,
about
no,
the
no, no.
API.
API resources. Yeah, built in
Okay. Then pod security policy,
for security for
PSP.
PSP.
Yeah. Then we have Kubebench and other, but
No,
maybe
no,
those
no.
are
That's it.
tools. Those are tools.
Dot tools. Yeah.
What other API resources? We have
Seek
the
service account
service account. Yeah.
roles.
And a role RBAC,
Yeah, roles, cluster role.
role binding. Yeah.
Yeah, role binding.
Role binding, cluster role binding.
Cluster role binding. I'm just not writing it, spelling mistake. I'm doing it. So role
Yeah. Yeah.
cluster role
Uh,
binding. One more CSR.
CSR,
Yeah.
right?
So these are the API resources, which,
Correct.
yeah. Now, one more thing, this is the API resources. Now let's talk about the commands, which you can use for these commands are, you have to practice it on a daily basis.
Mhm.
So what's are the commands we use for the securing the cluster?
So, I mean, mostly kubectl, we are creating resources, right? Like network policy and all of that. So kubectl.
Kubectl. So some of the commands like a
Yeah.
drain, uh, I'll just copy this one. Here exec,
Yeah.
attach, logs, describe,
Attach was what? What was that? Attach.
attach when you can attach to the PID one. PID one of the container.
Okay, okay.
PID one,
Mm-hmm.
remember that I said, right?
Yeah, yeah, yeah. Okay.
Describe,
Describe,
codon,
kubectl,
codon,
yeah, explain,
uncodon,
yeah,
codon, cordon, spelling correct.
don,
Done. Uncodon.
con,
Ah. Explain. What else? Proxy. What else?
yeah, run,
Run is for the running that. It's okay.
pod,
Not
yeah, okay,
not for the security.
right,
Related. Yeah. So these are the commands. Please remember that, which is specifically for uh, this one. Now let me just recall myself one more time. So certificates. See here.
mm-hmm.
Certificates. Cluster info top codon uncodon drain tent. Yeah. Tent and proxy auth and customize resources. Yeah, so these are the commands which you have to practice it a lot on daily basis. Now, so you got to know all these API resources, you are comfortable. Now
Yep,
commands, you are comfortable. Now process. First understand that process means understand that what you want to secure. So first start with applications. Do you have control? No control right now. After that you have a ways to secure Docker image. Okay. After
mm-hmm.
that, what should be secured? Docker
Container,
registry.
registry,
Yeah.
okay,
Docker registry. After that you have to contain can I use the shortcut? Container runtime interface. Will you remember this?
yeah,
Yeah. After that, kernel. Okay. And this is the one. So registry, CRI done, kernel, and host security is also important. Then CRI and kernel. Okay. Apps, I mean programming and all practices is not under your control. I'll keep it out of the scene.
yeah,
Okay.
yeah,
Yeah.
sure,
So for the image, what you have to do, you have to find out the one tool for first linting, then
linting,
yeah, and then scanning, image scanning. Okay.
yeah,
A registry, you have to do one tool for what is that? Signing, spelling
mm-hmm.
mistake, signing. Okay. And
Mm-hmm.
linting is done, scanning is done. In fact, registry level also scanning is available. Okay, so this is
Mm-hmm.
the one. Now after that you'll go for that's one tool for each one of this. Okay, you have to find out. Now host machine. So host machine, there are so many tools by the way. So some of the tools you would like to tell me. How can you protect the host machine? System hardening we call it. So
So system hardening, at the VM level, we didn't do anything, right? Like at the master or the
SSC,
uh,
we did know system hardening,
seccom,
setcomp, yeah,
seccom,
and one more, uh, dig, right?
Falco,
Falco
sysdig.
is runtime. Falco is runtime. So
Which one dig you are saying?
um, just a second, hold on. So
Mhm.
gvisor, this one. So yeah, so sysdig, you can use this official
Mhm.
tool for this. All these are I'm talking about, which is recommended in the Kubernetes. So
Yep,
here, okay. So system hardening app armor, you can use it for container runtime armor.
yep.
You can use gvisor, uh, gvisor, visor,
Falco.
run, run C to secure run C. Run C, run secure, run SC, run secure
Mm.
C. Yeah, so there's one more tool which we can use it. Run Javas are done. Network policy, I think we discussed somewhere in API. Yeah, so
Yeah,
that is done. Falco, yeah. So Falco, you have to practice Falco. Tup, uh, uh,
tough.
tough, yeah, tough. Uh, now here, CubeSec, CubeSec. This is for
Mhm.
image scanning, SAST, uh, KMS. You can Vault. I will suggest you Vault, or let's use the Kubernetes Secret Manager. Kubernetes Secret Secret Manager. This tools also you can use it. Now scanning is done, static is done via the kube spec. Supply chain, one tool I am forgetting here. So mm, registry. So which registry you are using? Now it's up to you. gvisor, Kata containers, Kata containers for runtime,
Mhm.
and gvisor I have used it. Yeah. So this is so far I think it's done. Now let's look for the last here. Uh, pod to pod MLTS. That's a proxy sandbox control. So MLTS at
MTLS.
MTLS. Yeah, MTLS and secure container done. Secret management KMS I have already KMS world I have added. More or less it's done. Let me remind myself. I think two I'm missing. So, uh, uh, Trivi, yeah. Trivi is pending, so I was feeling like missing.
Mhm.
And one more, Opa for policies. Okay.
Mhm.
Let me confirm. Opa is done, Tough is done. PSP, did I add it? Yeah.
Yeah.
Notary is pending. So Notary. Notary, by the way, is getting deprecated with somewhere I read, but again you get updated with it. Notary.
Mhm.
So yep. So overall, you don't have to become a master in anything, but you need to practice everything at a high level. So these are the tools. So pro in this resources, pro in these commands, this flow, and all these tools, different tool for different purposes.
Okay.
Understood?
Yeah.
This is the summary of it. All these product what we use, everything is open source except that Vault has a some part of Vault. Did I mention? No, a secret manager. Vault has a some part of enterprise things, but open source is also available for that. HashiCorp. uh, yeah, did you understand that? So
Yeah.
each tools you have to practice it with the Kubernetes context only. Not you should go into the each tool, and if you have a time you can do that anyways. But yeah, so this is the thing. Okay, so this is the session again. You know, if you get stuck, you can budge me over the WhatsApp and
Mhm.
get going.
Sure.
Any questions you have?
Mm.
This page always look at it because in fact CNCF they want you to look at for this project. Anything related to security, you should check this out.
Mhm. So just one question. So in a typical production-like environment, like you gave example of Prometheus, ELK, and all, right?
Mhm.
So what should be the ideal tools that you will recommend in a production-like
Yeah.
environment
For
for
the
Kubernetes security?
So for the monitoring purpose, I think somewhere here we discuss. See, for the monitoring purpose, these are the best combination as per my view. For example, one
Correct.
more thing you want to implement here, service mesh, which we have not discussed actually. Service mesh. Do you know that?
Istio.
Huh. So multiple products we have. We have Istio with Envoy. Envoy is a running as an agent, or you can use a console also, or you can use Lungder also. Linker, linkered.
Incurred.
So yeah, so you can use this one also. There's one more product which you can use, registry. microservices registry, MS registry. So registry means what? Registry means where you can register all the API services. So MS registry, it can be used ambassador, something like that. Okay. So here, everywhere the security can be implemented. So here you can keep monitoring the logs. Here infrastructure traces, alerts, anyway service mesh also certificate you can apply and all stuff like that. Microservices registry, here you can use it. So yeah, multiple tools. These are the production ready.
And there is no end-to-end or integrated tool like in the market
No,
for
it's not. It's not.
offering.
It's not possible. Also, think about it. No, this we are
Mm-hmm.
going in the world of distributed world. So
Mm-hmm.
tools cannot be centralized.
Centralized, yeah. But maybe someone is offering a service like a Kubernetes security where they are bundling all these tools and giving as a
So most of the time, this
service.
cloud people are developing solution, but no one is using them. Cloud people means AWS, Azure, and Google Cloud, but no
Oh,
one
is
is
it there?
using.
People are not just not using it. Why
Yeah.
is that?
Um, See, let's say I'll ask you simple way. Don't use Kubernetes, use the ECS. Will you use it? Simple.
Mhm.
ECS also do the same thing like a Kubernetes, right?
But you are getting support and you are getting a managed service, right?
Yeah, but no one is using ECS is died services. So it's very difficult because of it's like developer friendly plus also like how adoption rates are there. It's very difficult to find out actually. You know what we do, what I feel actually. There are few organizations, those who do some sort of practice making. For example, Google, Microsoft, or some Facebook and something like that. And whatever they do, all the developers start following the same process, and we started same using the same thing. So, for example, container concept has come from the Google only. Kubernetes concept has come from the Google
Come
only.
from Google, yeah,
Yeah,
yeah.
and this you see the LinkedIn, they have because of them, they all the JS libraries are there. Because of Yahoo, there all the JS libraries are there, JavaScript libraries.
Mm-hmm.
So it depends
Mm-hmm.
on that. Now, yeah, it's like that.
Hello everyone, if you would like to access the remaining videos of this playlist of 50 plus more tools which are coming under DevOps, DevSecOps, SRE, DataOps, GitOps, etc. Kindly become our channel members by clicking on the joining button. You would have access to 100s of playlists and 1000s of videos lifetime access with this membership. Enjoy.
Thanks for watching. Want to study further? Join our training programs today.